right, guys, we got a little bit of logic going on up in here. If you see something like this, a times b equals 0, what do you know? Well, you know that either a equals 0 or b equals 0. It just has to be that way, right? This is just necessary. Why? Because you cannot multiply some kind of like a positive number or whatever by another positive number or negative number, fraction, decimal. If neither of these are 0, you're never gonna get 0. It's not possible. You guys can pause the video right now and try to multiply a whole bunch of random numbers, neither of which is 0, and it's not gonna be 0. So in order to get 0, one of these numbers has to be 0. This is a very useful rule. How are we going to use it? Well, you might see something like this. A plus b times a minus b equals 0. And your brains are already firing. You're like, oh my gosh, I know what this is. Difference of squares, a squared minus b squared. Like, that's what that turns out to be. I already know that. That's cool. That's good. That's not what we're going to do in this particular thing, but I'm so glad that your brain's there. Okay. In this particular thing, what we can say is that either, so if we're starting to solve for a or something like that, we know either a plus b is equal to 0, that whole quantity, a plus b is equal to 0, or the whole quantity a minus b is equal to 0. Now, it's probably not both. Every once in a while it'll be both, but probably it's not. Most likely, okay? But one of these two is equal to 0, and we can kind of solve for them, and then we'll use some other things to figure out which one it is and what actually works out, okay? But this is like step 1. You see this and it equals 0, and you're like, okay, cool. Either this thing equals 0 or that thing equals 0, because these two big chunks are being multiplied together, and therefore I know that one of those two things being multiplied is going to be equal to 0. So, one thing that you guys try to do all the time, right? This is a caveat here. This is not a thing. One thing you guys try to do is you're like, okay, I got this. All right, so a times b equals 36, right? So now either a equals 36 or b equals 36. This is obviously ridiculous, but that's okay. Why? Because a could be 2 and b could be 18. Or, it is possible that a could be 1 and b could be 36, but that's not the only option. A could be 4 and B could be 9. Or A could be 6 and B could be 6, right? And they both could be 6. So there's lots and lots of other options there. And that only accounts for the positive whole number things, right? So if you take into account negatives and you take into account decimals and, fractions and all that stuff, there are so many endless possibilities of what A and B could be that there is no way to say for sure that it's 36. Either number is 36. So this is not how it works. It doesn't work this way. That's not it. What does work is when we have equals 0. So anytime it equals 0, then you can use this lovely rule. It doesn't work for any other number, no other number in the entire world, only 0. All right. The other thing that I want to give you a little bit of a hint here, okay? Anytime you have something that could be set equal to 0, okay, like it's actually in the problem, you could just like subtract 4 from both sides and then you would have 0 on the one side. Hint, hint, nudge, nudge. You might want to do that because you can use this rule then. And if you can use this rule, it's so helpful in solving for A, solving for B, whatever you're trying to solve for, right? X, Y, whatever variable, it doesn't make any difference. So that is the end of this logical rule. Don't forget it. Use it all the time. Ready, set, go.